Okay, so this video is going to be my demonstrating how to use synthetic division in order to divide polynomials. And I'm still using the mouse to do these presentations. Hopefully, my digital pen will arrive soon. Okay, let's look at the first example. We've looked at a couple of videos, and by now you probably have a general idea of how to do synthetic division. Most students like synthetic division. It's just very straightforward. You just have to make sure that you line up your columns correctly. So let's do a few problems together. The first problem wants me to take 2x cubed minus 5x squared minus 4x minus 25 and we will divide that by x minus 4. Now there's another method called long division, but we're not going to use long division. But if you would like another method, feel free to Google that or maybe do a YouTube search on how to solve using long division. Or if you want to see me before or after school, very briefly, I can show you how to do it using long division. But synthetic division is the most popular method, so that's the one that we tend to go for here at Holloway. The first thing we do is we tend to put a box here. And then we look at the denominator and notice that x cannot be 4 because 4 minus 4 would give you 0. So I'm going to put the 4 in the timeout box because it's bad, right? You cannot use 4. Actually, we will use 4, and that's why we're going to put it in the box. And then we take the coefficients and we write them next to the 4 on the outside of the box. And notice I do not have any gaps because I start off with a power of 3, then a power of 2, then a power of 1, and finally a power of 0, which is just 1. So we don't write that. And that's going to give me 2, negative 5, goodness, negative 4, and negative 25. And then I go and I draw a line here, put some space between the numbers so you can work. And we always start off by taking this first coefficient, which in this case is 2, and we drop it down. Once we drop the 2 down, that starts the process. So let's finish this. I'm going to multiply 4 times 2, which is 8. And once I multiply, I just add, right? I'm going to say negative 5 plus 8 is 3. Now I multiply the 4 here times the 3, which gives me 12, positive 12. And then I just add that column, and negative 4 plus 12 gives me positive 8. Then I multiply 4 times the 8, which is 32. And then 32 minus 25 is going to be what? Right, 7. Okay, so students tend to get this part correct. They tend to mess up on writing the final solution. But we have to remember that we actually divided one polynomial, right, into another. So the answer is going to be a polynomial. And notice that we started off with a power of 3, but since we divided by a power of 1, our answer is going to be a power of 2, right? Because when you divide, you subtract exponents. So let's see, that has to be a 2x to the power of 2, right? Because we started off with a power of 3, but we divided by x, so that's going to give me a power of 2 plus 3x plus 8. And this here is our remainder. So how do we handle the remainder? Well, we just say plus the remainder over x minus 4 because that's what we divided everything by. This is the solution to the problem. And of course, x cannot be 4. How come x cannot be 4? Because we can't divide by 0, and if x is 4, we would have a 0 in the denominator. So the final answer is 2x squared plus 3x plus 8 plus a remainder of 7 over x minus 4. That takes care of the first problem. Let's do another problem. Suppose I have x squared plus 2x minus 63 divided by x plus 9 and again we're just dividing here. I'm going to show you two ways to do this one because I noticed something about the numerator that's interesting. I know, for example, that 9 times 7 is 63. Numerator, right? I could factor that out. I'll keep the denominator the same. And the reason I'm seeing this is because I've done these for so long, I've just sort of learned to expect things like this to happen. So let's see, what numbers multiply together to give me 63 that have a difference of 2? Well, like I said, I know that 9 times 7 is 63, and the signs are going to be different. The biggest takes the plus, so I'm going to say plus 9 minus 7. So I have factored that numerator, and since I have factored the numerator, notice that the x plus 9's cancel, and the final answer is x minus 7. Now you may be thinking, okay, I would have never noticed that because I'm trying to learn how to do synthetic division. Would I get the same answer? And the answer is yes. So let's solve it this time using synthetic division. And to do synthetic division, of course, I'm going to look in the denominator. And since x cannot be negative 9, I'm going to put the negative 9 in the box. And notice that my coefficients this time are 1, 2, and negative 63. And now I'm just going to do synthetic division, right? I'm going to drop the 1 down. That's the first thing we have to do. Drop down the 1. And then negative 9 times 1 is negative 9. And then I just add 2 minus 9 is negative 7. And then negative 9 times negative 7 gives me positive 63. And notice if I add negative 63 plus 63, my remainder is 0. So what's the final answer? Well, we started with a power of 2, and we divided by x to the power of 1. So that's going to be x to the power of 1, 1x to the power of 1, minus 7. I got the same answer using synthetic division that I got by factoring. Now, you will not always be able to factor. In fact, when you're learning synthetic division, most of your problems will not allow you to do that. But I do want to show you that sometimes there is more than one way to do a problem. Let's do another problem. Suppose I have 2x squared plus 6x minus 20. And I want to divide by 2x minus 4. Okay. Luckily, I can tell from the very beginning that I can factor a 2 out. I can divide 2 into every coefficient on the top row, and I can divide 2 by everything on the bottom. So let's do that. 2 goes into 2 one time. That leaves me 1x squared. And then 2 goes into 6x 3x times. That gives me 3x. Then I can divide 2 into negative 20, which will leave me negative 10. And then I can divide 2 into the bottom row. That will leave me x minus 2. Now this is just simplifying a fraction like you did probably in 5th or 6th grade. You just found a common divisor, and you just divide it by that number. So this fraction here is the same as this one. But this one is going to be easier to do. The one in red is going to be easier using synthetic division. You could do synthetic division for this denominator, but it would involve using a fraction, and nobody likes fractions. That includes me. So I went ahead and just reduced the fraction, and now I can do synthetic division. Since x cannot be 2, I'm going to put 2 in timeout, and my coefficients are 1 and 3 and negative 10. I'll draw my line here, and then I'm going to drop the 1 down, and then 2 times 1 is, of course, 2. I add those two numbers together. 3 plus 2 gives me 5. 5 times 2 gives me 10. Notice that when I add negative 10 and 10, my remainder is 0. So how do we write the final answer? Well, we started off with the power of 2. We ended up dividing by a power of 1, which means I have x to the power of 1. So let's say 1x to the power of 1 plus 5x to the power of 0, right? Which is just 1. So the answer for that one is x plus 5. I just realized that I could have also factored this numerator, and I would have gotten the same answer. So you may want to go back and try that. It's up to you. Okay, let's do another. Let's look at suppose you have a problem that is pretty much already solved. Suppose we have something like this. Instead of giving you the problem, I'm going to give you, let's say, a student solution. So let's say we have this. This is just about the process, right? This isn't really about the setup. So you have something like this, and let's say you have, you have a 2 here, which means you have to have, what, an 8 here, and then a negative 1 here because you add that column, and then you'll have a negative 4 here, which means you will have a negative 25 here, which means you will have a negative 100 here. Now, how did I get the negative 100? I just multiplied the 4, right, times negative 25. And then if you take 88 and add negative 100, you get negative 12. And then 4 times negative 12 is negative 48. So you'll have a remainder of 0, which is always great. So let's say you have that. I'm concerned about this. Would you know how to write the proper answer based on this solution here? So let's think about that for just a moment. This column here represents our remainder. So this is going to represent our whole number, right? Just our constant solution. So I know that negative 12 is the constant solution. And that means that this has to be the x to the power of 1 column, making this the x to the power of 2 column, which forces this to be my x to the power of 3 column. So the final answer should be 2x to the power of 3, 2x cubed, right? Minus 1x squared minus 25x minus 12. So I gave you sort of the setup on that one, and I went through and solved it, but I just wanted to see if you could figure out how to go from here to the solution. So always remember this last column is the remainder column, followed by the x to the power of 1 column, and then just work your way over, increasing your exponent by 1 each time. Let's do one more like that. Let's do one that maybe has a mistake in it. Let's see. Yeah, let's do one with a mistake. Let's see. Suppose you're given, let's say, x to the power of 4 plus 3x squared minus 4x minus 2. And let's say we're dividing by x minus 2. I don't know about you. I travel, I don't know, I guess quite a bit. I fly, you know, every couple of years I end up taking a trip that requires me to fly. I don't know about you, but I get really nervous when I get to the airport and I have to go through and have a body scan, right? They look at, you know, they scan you to make sure you don't have any weapons or sharp objects. And I really hate it sometimes because I will set off the alarm, right? It'll beep at me, which makes me panic. So I want to see if you can see what might set off your alarm. Let's say a student has this problem here, and he's asked to solve it using synthetic division. So he puts the 2 in the box here, which is a good thing, right? He puts 2 here. Now, if this had been plus 2, right, he would have had to put a negative 2, but that's not the case. And let me go back and fix this. Right, he had an x minus 2, so he'll use a positive 2 in the box. And then he says, okay, I'm going to put a 1 here because there's a 1, you know, in front of the x to the power of 4. And then he just goes ahead and puts the 3, and then the negative 4, and then the negative 2, like that, right? And then he does, you know, he does synthetic division. He brings the 1 down, and then he multiplies 2 times 1 and adds that to 3. And let's say he gets 5. That's great. Then he multiplies 5 times 2 to get 10, and then 10 minus 4 is what, 6. And then he does 12, and then he says 10 is the remainder. And then he writes the answer. Let's see, he writes it this way. X to the power of 3 plus 5x squared maybe, or something like that. So let's say he writes the answer, but there's a problem. The problem is this is not correct. Now the problem is not his multiplying and adding. All of that is fine, but he made a big mistake. Notice that there is no x to the power of 3 here, right? We have an x to the power of 4, and then we go down to x to the power of 2, but we have skipped x to the power of 3. So we have to imagine that there is a 0x to the power of 3 in there. In other words, we have to hold that place open so that we can do the columns correctly. In other words, we have 1x to the power of 4. We have 0 x's to the power of 3. Then we have 3 x's to the power of 2. Then we have negative 4 x's to the power of 1. And then we have negative 2 x to the power of 0. That's what should be in the box. It should be 1, 0, 3, negative 4, negative 2. So always remember to check your numerator to see whether or not they have skipped some of your exponents. They can leave out 1 or several. You know, you really need to check for that. So I will leave you with this, and I hope this video helped, and I appreciate your listening. Thank you.